at the point where we are transitioning from looking at truth tables and looking at the predicate calculus and transitioning that into what's known as mathematical proofwriting. Now, what is mathematical proofwriting? It is essentially the same thing as what you would do in truth tables, except you're not going to use the truth tables. So what was the point that we did previously? The point was you had some logical statement written however it was written. So let me actually go back here 2 slides so we have a picture of a truth table. Like, for example, on this one, you have some logical statement that you wrote in symbolic logic here, and you wanted to know, hey, what was the truth value of this compound statement? You then do all the scratch work in the truth table, and at the end of the day, we found that this guy here always has a truth value of true, and this is where we did the example for the definition of a tautology, which means it's always true. Well, we want to do the exact same thing with more complicated statements, and it turns out when you have more complicated statements, you can still put everything inside of a truth table, but typically you don't in math just because it starts getting too complicated too fast. Your truth tables would be like, oh, I don't know, like 20 lines deep or more type thing. And it actually turns out to, instead, people do something called proofwriting, which is do the logical deductions to get to, hey, we actually have a statement here that turns out to be a tautology. So this here we actually talked about last time, so let us actually jump into starting to look at what would you do to show that some statement is true if you're not going to be looking at a truth table. So let's go ahead and start this so it's a little bit bigger for you guys. So this is what we had previously, where these here are all of the background information. If you have all the background information, then you'll reach your conclusion. We want this thing to be a tautology. We know that if the if part of a statement is false, that means automatically, according to our truth table for implication, the entire if-then statement is flagged as true, which means the only time we're really going to be checking here is if the if part of the statement is true, so we assume all this stuff is true, then we need to show that we're only going to get true over here. We'll never get into the case where true implies false. Okay? So that's the key thing that we're going to be doing. Now, here's the sort of glue that holds all of this together. Okay? So this here is definitely an example that is not even close to being a math example. It is, however, a very, very basic situation of what you would start seeing when you look at proofwriting. Okay? So we've got 3 sentences. The first 2 are the sort of preparatory sentences, and the last sentence is a conclusion. That says, if I drive to work, I'll be tired. If I'm tired, I'll miss lunch. Thus, if I drive to work, I'll miss lunch. Now, we're going to just go ahead and assume that these first 2 sentences are true. Okay? If these first 2 sentences are true, do you think that this conclusion sentence down here seems to logically follow from the first 2 sentences? What do you guys think? It seems believable, right? So let's go ahead now and pull this into symbolic logic. So the first thing that you do with symbolic logic is you say, I do not want to deal with all of those words. This is not an English class. Okay? So you say, all right, well, I need to do symbols to represent what's going on. So you look at the big components. So the big components of the first sentence here are the if I drive to work, then I'll be tired. I didn't put in the word then, but you totally could have. So here we'll go ahead and grab this clause, I drive to work, and so we'll put a W for work. You could use a different letter. Okay? The next big one is the person's tired, so I abbreviated with just I'm tired, and I did T for tired. Okay? You can pick any letter you want, just make sure it's not a symbol you've already used for a different statement. And then go ahead and looking at the second sentence, it already talks about I'm tired, so we don't need a new symbol. And this one here says, then I'll miss lunch. So we'll go ahead and say, hey, I'll actually, instead of taking the negation, so missing lunch, I'll just say I have lunch. Okay? Again, you could have L be I'll miss lunch. I went ahead and did it in the positive. Now we can go ahead and convert this thing, the 3 sentences, into symbols. The first one would be an if-then statement. So if I drive to work, then I'll be tired. So in symbols, if W, then T. The second one would be if I'm tired. So if T, then not lunch. So I don't get lunch. And then for the conclusion, it will be if W, then I miss lunch. So notice that would then be the way to put it together into sentences. Now, in terms of seeing if this statement actually is true or not, in other words, if the entirety, if the whole logical process of all three sentences is true, what are you actually looking at if you put it into a truth table? So right now, we're still looking at the truth table side. So in terms of the truth table side, what you would need is you'd have to have that both the first two sentences work. So this is if W implies T, and, notice the and, T implies not L. So both of those together imply then that W implies not L. So from a logical standpoint, from symbolic logic or predicate calculus standpoint, that's the sentence that we're trying to show is a tautology. Okay? So that's the thing that we actually need to do behind the scenes. Okay? Everybody comfortable with what it is that's going on here in terms of converting those three sentences into symbols? Now, we're not going to do this for probably the rest of the day, but for this one here, this is the tie-over example between the symbolic logic and when we don't use the symbols as much. All right, seeing no big questions come through, the next half of this example I'm going to throw to you guys. Okay? So we're going to do it in two parts. One of the parts is a poll everywhere question, which I haven't activated yet, so I'll do that as I send you guys into the breakout sessions. But I'm going to let you guys put together the truth table for this compound statement. Okay? So let me go ahead and pull this out so I can pull up the second one. If you have it or if you don't, what I did is I actually already wrote out for you guys. Let me go ahead and stop sharing that one for just a second. I already wrote out for you guys this one here. So if you pulled your activity 3 already from Canvas, you actually already have that statement written out. If you didn't do that, no worries. Right now, jot down what this compound statement is real quickly. That way you have it, because once we go into the breakout sessions, everything I'm sharing with you is just going to disappear. Okay. So, questions for you guys on what the directions are before we jump into the breakout sessions where you can't hear me as much? I am seeing no questions come in from you guys. Did everybody get this written down that need to have it written down? If you didn't, say no real quick and I'll wait for you. All right, I'm seeing no no's then. In that case, what I'm going to do is I'm going to go ahead and throw you guys into your breakout sessions. There are currently 4 of them up and activated. You guys have all been thrown into those breakout sessions randomly as you entered today. So since there's 4 of them, there should be 4 or 5 of you in each of the breakout sessions. We've done this now a couple of times, so hopefully you guys are okay with what's about to happen. I would definitely recommend using the whiteboard feature in there. That way you can all see as you're writing out truth table stuff, although a number of you in the past have done shared desktop, which also works just fine too. All right, so I'm going to go ahead and throw you guys into those breakout sessions starting in 3, 2, 1. Here we go. Oh no, just a second. Okay, yeah, I got a note from, I think it's your session. It may be an issue in starting it. Just a second, guys. All right, are you guys still outside of a breakout session? Trevor, Joseph, Jennifer? Yeah, or more? All right, I'm going to see about ending the breakout sessions and starting them over because it looks like for a couple of people, we just didn't jump into the session for whatever reason. So just a second, we're going to stop and start here.